I'm David. Today's fundamental module is going to be dealing with the cable operated electric park brake. We're going to be having a look at the components of the system, circuit diagram and operation, functions of the electric park brake, why there's a trend towards electric park brakes, and finally some of the special features of our latest vehicles. Before we have a look at the components, let's go over to the diagram and see how the system works. Let's start by having a look at a block diagram of our electric park brake module. We'll have a look at the inputs and the outputs. On our input side we have B+, an ignition that supplies all of our power needs for the module. And of course we've got a ground. There's also a module temperature sensor and an apply and release button. Via our bus we get wheel speed, engine torque, gear information and brake pedal signal. When the module is armed with all this information, it can now operate the apply and release motor and via the bus send information to the instrument cluster, ABS and traction control. Moving on to the schematic, we'll have a look at the connections to the module. Here we see our park brake control module, and on pin A we have a B+ coming through a fuse. On pin P we see our ignition feed, and on pin H we see our ground. Here we see a high side driver connected to pin N, and that goes up through our switch and is connected to pin C and a pull down circuit. This is used as a self-test. When the module is powered up, the driver closes and the signal is seen at pin C. The module now knows that that circuit is okay. With our park brake control switch in its normal position, on the apply side we have B+ coming from pin R up through the switch down to pin D where there's a pull down circuit. This means the signal wire on pin D with the switch in its normal position will be 12 volts. When the module sees this, it knows that that switch is not applied. To apply the park brake, we operate the park brake switch. This removes the B+ from pin R going to pin D. Pin D will now go from B+ to 0 volts. At the same time, the B+ from pin R will go to pin C. Pin C will now go from 0 volts to B+. The module sees this as a brake apply request. If the module doesn't see both of these signals, the brake will not apply. For the release side, we get B+ from pin S up through our switch and down to a pull down circuit on pin B. Again, the module will see 12 volts on pin B when the switch is not applied. To release the park brake, we operate the park brake release switch. This removes the B+ from pin S going to pin B. Pin B will now go from B+ to 0 volts. The B+ from pin S will go to pin C. Pin C will now go from 0 volts to B+. The module will see this as a brake release request. If the module doesn't see both signals, the brakes will not release. We need one other thing for the park brake to release, and that's the operation of the foot brake. And that comes from the bus. So that takes care of our powers and grounds and our switch connections. And what we're left with is communication via the bus. So we have wheel speed, engine torque, gear information and brake pedal signal coming into the module via the bus and we have instrument cluster, ABS and traction control information going out on the bus. Signals to the instrument cluster are pretty obvious. That's going to turn on the lights that we require. But you may wonder why ABS and traction control are there. We'll have a demonstration later of the emergency stop feature, and that'll make it all clear. So that's the schematic and its operation. Let's have a look under the vehicle at some of the parts. And here we can see one of the 4 wheel speed sensors. The park brake cable goes to a standard shoe-in-hat designed park brake. The module in this vehicle is mounted underneath. And if we remove the end cover, we can see the electrical connector. To apply the park brake, we lift the park brake switch. On the instrument cluster, we'll see the light flashing as the brake applies. When the light goes steady, the brake is fully applied. To release the park brake, we push the switch down. If we don't have our foot on the brake, a warning will come up on the instrument cluster. So to release the park brake, we need our foot on the brake before operating the switch. The light will go out indicating that the brake has been released. There's another way of releasing the park brake. If the vehicle is in drive or reverse and you apply your foot to the accelerator, a torque request comes through to the module and the brakes will be released. Let's have a look at the emergency stop feature. All I have to do is pull up on the park brake switch for more than 1 second, and then the EBCM will take over and bring the car to a stand without the intervention of the brake pedal. Once the vehicle is stationary, the park brake will be applied. That's our introduction to cable-operated electric park brakes. Some newer vehicles have even more features. For example, once the park brake has been applied, operating the button a second time causes the brakes to apply harder. Some vehicles have 2-stage emergency stop features, depending upon whether your foot is on or off the brake pedal. But the one I like the most is when the park brake's applied, and even if the driver has just got out of the vehicle and the module senses any movement, it will apply the brakes even harder. And this is great if you tow a trailer. That's our informative look at cable-operated park brake systems. Always remember, training is the key to your success.